All right, so you've brought in your data using ELK, and you've got a city plan that you want to work with. What I'd like to do now is to adapt some of this, because we don't actually need this kind of live connection to this database. I just want to bake this geometry. So I can get rid of the display. I'm going to keep the polylines, but I'm going to bake this geometry. So we'll bake this. And actually, before I do, why don't we set up a good workflow? And I'm going to set layer 1 to be called existing. Name it something simple. And then let's bake the polyline geometry. And we'll put it on now existing, and we can group it together. We can say, okay. Now we have that geometry ready to go. And probably for the most part, and to save us some computing power, I just want to delete that, because the city information isn't really going to change now. It's on our red layer, which is maybe a little confusing given that grasshopper is red and green. So why don't I set this to be gold color? It's a little hard to see on my screen, but maybe we'll let that stay here. Maybe I'll change it black for a second. Dark gray. I want to fill in just a couple of things here. And so let's add this, just to add a few lines. Like there were just a couple key elements that were missing. Especially around the main square. It's probably a little bit better if these things are closed. Don't get too crazy, as I'm about to. Okay, so we've got that. And what I might do is just to ungroup it all and then explode it and regroup it all back together. And so let's ungroup it. I'm going to select it all, explode it. And we can see there's over 8,000 lines. I'll join it. And now we can see there's 230 closed curves, 154 open curves. And then I'll group it back together. So now that's grouped. And I can lock it. And we just want to be careful when we start exporting it that we're going to want to make sure that we remember that it's locked. Okay, let's do a couple of things now that we have that information. First of all, let's draw a curve. Maybe I want to make a new or rename one of my layers. Let's call it path. I'll make that current. And let's draw a line going through the plaza space, piazza. So I'm going to start outside the major space. Come into the main space. And through. And I'm using a NURBS curve to do this. also not being super precise. But now we have that path. And so that's good. That'll be our path that starts to set us up to set the movement through the city. So let's do a couple of things. Maybe let's start with just a point. So as a way to introduce the key tool that we'll be using is now we have a point in the main space. We're going to use a tool called Isovist. And I think I mentioned this at the beginning. The Isovist is basically, it's going to set a series of lines radiating out from a point in space, and that will go until it reaches an obstruction. And so Isovist is under intersect and under mathematical. We can see Isovist and Isovist ray. So let's pull down Isovist and see what it's looking for and what we get here. And so there's a couple of things that we have. I also want to introduce a new tool as it relates to this. So let's start with the plane. We've defined planes in a number of ways. Let's use XY. It's our XY plane. And we'll set that for the plane. And we're going to make two sliders. Let's say we'll start with 100 for each of them, and we'll go from there. We'll see if they work. We'll set the count to 100 and the radius to 100. And our origin, let's set a point for this. Plug in our point. We'll grab our point by setting one point, and we'll use this point in the space. Let's set the plane for us. We can hide that. And now we need obstacles. What I'm going to use for obstacles, this is a new tool. We're going to use a geometry pipeline. So under geometry, we can see geometry pipeline. What's really nice about this is that we just set a series of curves and lines onto a layer. And so we'll use geometry pipeline. And what it will do is it'll basically query something based on a layer or based on names or something else. So under layer, we can see it's just a wildcard here. Let's double click layer. And I'm going to type existing. Say okay. And then what I want to do is to choose, we can toggle what's nice between, we can pull different information from those layers, either points, curves, B-rep surfaces, or solids. And so I'm going to double click the curves. And now we can see all of our lines, many of our lines, not all of our lines for some reason. We have a bit of a problem. Not all of our lines got picked up. I wonder why that is. Because they're on a different layer. I bet it's because I drew them. Or these, yep, these are the buildings that I messed with. So if I just select these, I'm going to set, it's on a different layer, I'll set it to existing. And now as I come back and preview that, now those lines are all part of it. So, and you can see that was a great example of the fact that the geometry that wasn't included, that I thought should be included, wasn't on the existing layer. So now it is. So now let's plug in the existing lines into the obstacles. And now we can see what just happened is that there's a series of points that have essentially radiated out from our center point, or from the point that we set, out to the point where it hits something else. And so there's a couple of things that are happening. The first is the count. As we turn this down, you'll see these points begin to reduce. So this is basically the resolution for that boundary as it wraps around. So 100 may be enough. It may not be enough, depending on what resolution you're looking for. So I can increase this. Your computer may start to get a little slow. You'll see if it makes sense. The next is the radius. And so for the most part, from this center point, the maximum point that we're getting is 100. But if I increase this, and there'll be instances where as we move down the street, we'll be able to see much further than 100 meters. But as I move this out now, you can see that these points are moving further out. And so this gives us a really nice boundary. The radius allows us to even just pull some of these in. That's okay. And so this is a series of points. So here we can make again, a polyline. We could connect all of these vertices, and let's see, is it closed? So now we can hide our points. We have a polyline that wraps around that, and we can do the same thing. We can make a boundary BREP, boundary surface. We can see there's an obelisk in the space because of where our point is. That's now, we can't see this portion of the building because of that obelisk. You'll also see the resolution again, given where those points were, it's not exactly matching that obelisk, right? We have to increase that resolution for it to work. We could set our custom preview. And now we end up with a very nice representation of what we could see from 360 degrees from this point in space. As I move that point, watch what happens. We can start to see, and we'll see that the kind of silhouette that's created from some of these things shifts. Again, there's the point, there's the obelisk in the space. We can't see this building yet because of where we are. It's blocked by this building. Seems like we could increase the resolution a little bit. We'll see. You can see we're starting to get, it's a little bit off in some of these areas. And you can start to get a sense for if that is working, if you have enough resolution. So that's a really great tool. It automates a number of steps for us, right? It takes that point, projects all those points out, finds its intersection with the obstacles that are there. So for the next step, what I wanted to do was to try and figure out, rather than 360 degrees, what's a kind of field of view as I move through a space, because I'm moving on a path and I'm in it and in a direction, and I'm not looking behind me, I'm looking ahead as I move through the space. So I took the Isovist view and I started to think about, okay, how could we start to control some of this? And so the way that I want to do that is to create a sublist. And so we'll look at our lists, and here we can even, let's disable from our polyline for a second. We'll turn back on our Isovist view from those points. And so here is a way just to work through this process rather than me just telling you how to get to the final product. I want to just share a couple of steps related to this. So we have, here's a panel with a list. This list has, as we could probably guess, 200 points from 0 to 199. each of these points in the list corresponds to the points that we see being radiated here. And so what I wanted to do was to take that list, but only take some of the points. And so what I had to do is figure out, so let's take a look at lists, and there's different types of list options. So I wanted to extract. So using sublist, which is something we haven't used yet, we've looked at item index, we've looked at list item. So sublist is that we want to extract a subset from the list. And what I wanted to do, rather than take all 360 degrees, because that's what the Isovist view gives us, it doesn't give us a parameter to control that range of view. So instead, at least I don't think it does, we can double check. Radius, account. And so when we right click on it, we just get the standard options here. So with the list and the sublist, if I pull down sublist for a second, this allows us to get the list, which will be our points, a domain for them, and whether or not it should wrap. And so wrap, I'm going to set to false. And domain. So let's construct a domain so that we can understand what we're working with here. And so what I wanted to do was to say, give me the list of items, right? We know that there are 200 points. And so I can use this same slider, and I want to multiply my 200 because I want to get a subset of that. So let's look at this here, and I'll do a multiplication for each one. And let me plug in the count into A for both cases. I can plug this into the domain, and then I'm going to use my new technique of creating a panel, a very small panel with one number. I'll do this for both. And what I was thinking, or let's start with it, and let's say 0.25 to 0.75. And this will just give us 50% of the points. I can hide the Isovist, right? Because the Isovist is giving us all 300 points. And now we're getting the sublist. So the sublist is what we see here. So what's happening is that we're going from 0.25. So let's imagine this working all the way around a kind of radius. What it's giving us is that it's starting with X, the X-axis as 0. And so if we rotate around the clock counterclockwise, it's getting to 25% of the clock. It's giving us from 25% to 75%, and then it's not giving us the rest. So now we start to get a sense for what we're including and what we're not including. And so let's go from 0.33 to 0.66. Now what we're going to get is 1/3 of that view on the back side. And so what we could do if we want to flip that around is that our domain, well, maybe it's okay because this is the way that I've been working. We can always just flip our curve so that we think we're moving in one direction if X is positive, but we can always flip it, and so that we can go from 0.33 to 0.66. The next thing that we'll have to do as a way to understand this, as a way to build the geometry, is if we add a polyline, connect the vertices, what we're getting are just the vertices as they wrap around. And what I really wanted in terms of constructing this other drawing type is I wanted to implicate that point in what's happening as a way of creating that boundary condition. And so the way that I did that is I created a weave, and we used this in a previous tutorial. And what I wanted to do was weave together a pattern. Mouse over, we can see the pattern is 0, then 1. And so that pattern will be my points. Let's see, the sublist will just be our point, will be item 1. Our sublist will be the other point. So we've woven those together. And now, actually want to move the polyline to the other side. Let's plug our list in here. And we'll do that. And so now we can see that with our weave, we go from, we just created a polyline from our first point, from our point out to our polyline and around. And now the trick is that we can just set closed to be true. And now this is a closed polyline all the way around, originating from our point. So we could do the same thing again, is we could create a boundary surface just as a way to visualize that. So if we move our point, we can see the way that this is moving. And so what I just did as a way to test it, I wasn't 100% sure that that was going to work, but I just rotated the point, which actually doesn't have any orientation to it, but I've rotated it, and that did not change the rotation for anything that's happening here. And the reason being is that it's tied to the XY plane, and our XY plane is what's setting our orientation as it relates to the domain, to the projection of those points. But this means now that we can change this if we understand the way that our planes work. So let me zoom out now. I'll zoom out here, because what I want to do is move from one point that I want to have a whole series of points created along the path. And so let's do this. Let's create, we'll move a few of these things over. So let's see. I don't want this boundary surface, this polyline. Maybe I'll move our display over there. This is our domain, and our sublist will all come after our Isovist. I don't think we need the panel anymore. You should understand what's happening with the Isovist. But let's add a little bit more control along the way as it relates to this. So let's go from, we're not going to use our XY plane anymore, nor are we going to use that point. So I'm going to delete that point in Rhino. Now we're going to work with our path and the way that our path moves through the space. So in order to do that, let's start with our curve. And we'll make a curve container. And we'll set one curve, and we'll select the curve that we had there. So this will be the path as it moves through the city. Let's divide the curve. And this is similar to the previous tutorial in that what we remember doing is, or what we should remember doing, is working with the divide curve and knowing that we can get tangents along the curve at any one of those points. And I believe it defaults to 10. So let's set a slider for, I don't know, 25. But let's turn it down to like 4 or 5 to start. We'll set that as the count. And at least now we'll have a series of points, not too many points yet, but we can start to understand if this is working and if it's working the way that we want it to. So now where we had 1 point previously, now we have a list of points. And so like we did in the last tutorial, let's develop a plane at each of those points. And let's do that with a line, which will be the start point, the direction, and the length. And so let's use the point to start the line. Let's use the tangent as a direction. And let's set the length. In the end, the length isn't going to matter because we're only going to use this line as a way to help us create a plane. But now, as I zoom in, we can see we have our point, and now we have a line that's tangent to that point along that curve at that point. And so we have directionality at every point along the curve as it moves through. And so with that, let's, like we did in the last tutorial, let's rotate a line 90 degrees. And so as we rotate this, let's set this to be, so the geometry that we're going to rotate is our line. The angle we want to set to degrees. We set a very small panel, set to 90. And our plane will be equal to, let's cheat for now and set our plane equal to our point, which again defaults to XY. We're working in the plan, so XY is fine. So now we see we've got two perpendicular lines at that point. We can use these two lines anywhere along that path to define a plane. And so, like we did previously, we're going to use the plane based on line and line. And so line A is going to be our first line. Our second line, clean these up a little bit, will be our rotated line. And so now we see we end up with a plane at each of these points. That plane now has an orientation to it. And this is how we get around that problem that we had a second ago, that the point itself doesn't have an orientation, but because we want a selected domain from all of those points radiating out, we can do that using the plane. And so now we'll set this may or may not work, but I think what I did previously, well, let's see if it works. Let's plug this plane into plane. It's not liking that, and oh, it did work actually. The way that I did it before is I had an extra component that was the origin for the plane, but it doesn't seem like we actually need it. And so let's see what's happening here. So from this point, we can see that we're moving in this direction. If we want to flip directions, that's an easy enough thing to do, is that we can always add a flip curve. And you'll see if we just put the curve in and do that with it, these should move in the other direction. So as we come out on this side, now this is the rest of that radius as it moves through. And so you can choose whether you want to flip the curve or not. And so we can leave that there depending. So we have some of this. We can check. Let's go from We have 0.33 to 0.66. If we want to narrow that down a little bit, but that 0.33 to 0.66 is this. And so we could go from, we know that 0.5 is here. And so we could go from, let's say 0.4 to 0.6. And we can see that just trimmed off the field of view a little bit. And so you can see what makes sense for what you're doing, but we can use those two to define that. And let's see where we're at with this. We have all of that seems to be working. What we don't have is our stream isn't working. So we've plugged in our sublist. What do we need? We need our points that come all the way from our divide curve. So I'm going to go back to the divide curve, pull this all the way over and fill this into the weave. So now we can see we started to get closed boundaries, but it's a little bit crazy. The reason why it's a little bit crazy is that what we want to do is at some point we want to flatten down some of these. So let's look at, I think what we want to do, because we can see the two different lines or two different types of data coming into the weave, one is grafted and one is not. And so let's graft the first points as they come in, and that worked. And so now we end up with these different boundaries from each of those points. So let's get a better sense if this is working. Let's hide some of these things. We'll hide our sublist, can hide our weave, can hide our polyline. We have our boundary surfaces. While we're here, let's pull our custom preview over, plug this in. We can even make these transparent. The way that we can make a display transparent is with the alpha channel down at the bottom. So let's just turn this and we can see it becomes more and more transparent. And we'll set that. So let's hide our boundary objects. And let's see if there's anything else. I guess we have our plane. We can hide our plane, our other lines, and even our points. And let's now increase, we can increase a few things. Let's increase our divisions. And this is going to, your computer may not be too happy with you, but you can increase your curve in terms of how it's divided. Hopefully this doesn't crash. Rather than sliding, you may want to just set that to be a number. We could even set it with a panel. It'll still take a minute to calculate these things. So now as I increase that to 43, which was maybe a bit excessive, we can see that there's 43 divisions of this curve along the way. And so as one moves along this path, we can see the way that that changes. And maybe I'll do what I suggested a second ago. We'll set this panel. Maybe I'll set this to be 20. Plug that in. And my computer still has to think for a bit whether I use the slider or not. But now we can begin to see from each point kind of what's happening with that. If we want to extend, there's only, it looks like a couple of moments where here maybe where we're seeing down that street, and this is the limit of the radius, as is this here. But under the Isofist, if we want to change the count of these or change the radius, we could do that. And that seems to be okay. So, and again, if we wanted to flip the direction and move the other way, Right here, we're moving from right to left through the main square. If we want to go from left to right, let's just simply flip the curve. And now we can see that that curve just flipped. So now we're moving from left to right through that main space. So last step is that while this isn't a terrible representation of these things, we can really fine tune this by bringing it into Illustrator. And so what I'll do is I want to grab two items with this. I want to bake my polylines. I don't actually want the boundary surface, but I do want the polyline. And so I will bake this and maybe put it on layer 3 as a grouped element. I'll say okay. And now if I remember I locked, or I guess it's unlocked now, I've got my city data. I've got my polylines of the Isovist view as it moves through. And I've also got my curve that is moving through that way. So what I would do is I would window crossing, select everything that's there. Let's say export selected. I'm going to export this as an Illustrator file. Prog, save it. Don't really care about any of these things. Say okay. And now let me open Illustrator. So in Illustrator now there's just a couple of simple steps. We'll find our file. It should be here. It's going to look a little funky at first, but with a couple of simple changes, we can see our layers are coming in. I might just hide each of those layers so I can work on them. I'll select all of the existing layers. I'll change the stroke. That'll be a nice thin line. If I want, I could select everything on the layer. I can see how it looks if we flip it. You see there's a little funkiness in a few places, but it could work for us, or we could do both. But for now, I don't know why that just reverted back. Now we have some nice thin lines here. Let's turn on, here's our path if we need it. We could take our path and maybe give this a nice dashed line. Through the city. But what I've started to realize is that maybe we don't need the path because it's pretty clear once we do this, we have a really good understanding of the path through. And so what I've been doing is just setting the transparency very light. So there's 5%. We can increase it depending on the color that you have. Here's 10%. And we start to get the overlap of all of these elements within here. And see, maybe we increase the resolution in places, but it gives us a pretty good representation of all of the Isovist views. And maybe as we come into the space, we want this one to extend, or we want this one to extend. So we can work back and forth a couple of ways, looking at the length or the radius of the Isovist curve, the resolution of the Isovist curve. But with a couple of simple steps in Illustrator, given the simplicity that we have with the layers as they come in, we can really work iteratively between these things. Let's look even just at flipping. So we can look at this in a couple of different ways. We go back and even just change the color if we don't like the blue. just a gray tone. So I hope this works for you. It should. And what I'd like you to do is to look at a couple of different cities, start to develop a kind of understanding about what it might be like to move through the city, given this analysis type. And so we're developing a drawing and analysis type, but we're also in the background getting a sense for how we're managing some of that data, how we're controlling some of these things, and how we're weaving together some slightly different list items so that we can get the result that we want in the end. So let me know if you have any questions. For the students in the class, reread the assignment, make sure that you understand the constraints and the requirements for the assignment given these techniques. But hopefully you have some fun. And as always, I look forward to seeing what you come up with. Thanks.